Finding the nth term of a sequence, we let n starts at 1. Before we start discussing these problems, I have to let you know that this is the most hated and the most unpredictable exam problem. You never know what you will get on the exam. Sometimes on the exam you will get the pattern is easy to find. Sometimes the pattern is difficult to find. Depends on the preference of your instructor when your instructor is writing an exam. Now, what is the best way to prepare for the exam? There is no shortcut. You cannot say, okay, I can do this, then I can do the rest. That is not true in this type of problem. All you have to do when I was a student, so what I do is I go through the book and then I solve every single problem on the book. I have to train my brain. When I see this type of problem, usually the pattern, they will just go this way. So for example, the first one, I will give you more advice as we move on. The first sequence, we have 0, 3, A, 15, 24. So 0, A, 15, 24. First of all, you write them down, and then you let n starts at 1, right? So n equals to 1, 2, 3, 4, 5. And then you have to look back and forth, a lot of looking around. You have to look back and forth to see what the pattern is. So in this problem, n equals to 2, we have a 3. N equals to 3, we have an 8. But n equals to 1, we have a 0. So how do we make something 0? Can we square that? Because 2 square is close to 3. 8 square is close. 3 square is close to 8. 4 square is close to 15. So I will be thinking about a square. But 1 square is not a 0. So therefore, I have to try subtract 1 to see if that works. It turns out that works every single time. Now, what I'm trying to say is you have to solve many problems when you study, and you have to earn those experience. So what do I mean is when you are dealing with finding the pattern, most of the time it will just be square and then add or subtract a number, or double up the n or triple the n and then add or subtract a number. They usually go this way. So you multiply n by a number and then you add or subtract 1, you square the n and then you add or subtract 1, or you take n plus 1 and then multiply to another number. Usually they will just go like that, back and forth, but you have to earn a lot of experience to do this fast on exam, especially when the time is very tight. So let's say you have 15 minutes to do like 40 problems. You have to be fast. If you want to be fast, then you need experience. To get experience, you need to solve many problems from the book, or you look it up on Google. Okay, the next problem, I'm going to match all the colors for you. So 91, 82, 73, 64, 55, ... Okay, let's do the n. N equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5, so on and so forth. So this one, the pattern is an. So this one is pretty hard to figure out. This one is 100 minus 9 times n. So when n is equals to 1, 100 minus 9 is 91. When n is equals to 2, 100 minus 18 is 82. See? It's unpredictable, right? Can you figure this out in the middle of an exam? When the time is very tight, if you want to do it fast, do it accurate, then you need a lot of practice. All right, let's try the next one. The next one, we have 1, 3, 1, 3, 1, 3. So 1, 3, 1, 3, 1, 3. How do we make a pattern like this? N equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5, n equals to 6. If you take the n raised to a certain power, that is not going to work. How do you get a 1, 3, 1, 3, 1, 3? So it looks like we have 2, right? 2 minus 1 is 1. 2 plus 1 is 3. All right, then for the an, we start at a 2. How do you alternate the plus and the minus 1? The way you do this is you have negative 1 and then you raise to the n power. When n is equals to 1, 2 minus 1. When n is equals to 2, 2 plus 1. Okay, so let's try this one more time. When n is equals to 1, you have 2 minus 1. When n is equals to 2, this becomes a plus 1, so you have a 2 plus 1 equals to 3. All right, how about fraction. 1/2, negative 1 over 4, past 1 over 8, negative 1 over 16. So the minus sign alternates. How do we do that? When the sign alternates like that, so n equals to 1, to 2, to 3, and then to 4. When the sign alternates like that, think about negative 1 raised to some power. Let's start with n. Does that work? When n is equals to 1, no. When n is equals to 1, we have positive, so we have to add 1 to it. So now when n is equals to 1, we have a positive. 1 plus 1 is second power. Negative 1 raised to the second power is positive. So whenever n is odd plus 1 is even, negative 1 raised to an even power is positive. And then how about the fraction? The fraction, the top is always 1. The bottom, I can see that is n squared. I mean 2 raised to the nth power. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So on and so forth. All right. Moving on to the next problem. The next problem, we have a 1/3. Okay, match the color first. We have a 1/3, 2 over 9, 4 over 27, and then 8 over 81, n equals to 1, n equals to 2, n equals to 3, n equals to 4. So based on my number sense, I can see that both the bottom and the top has to raise to some power. So we have a to the n. The bottom, I can see that they are all base 3, so that will be 3 to the nth power. First power, second power, third power. You can see that very quickly. How about the top? The top, if you have 2 to the n, does that work? When n is equals to 1, 2 to the first power is not 1. When n is equals to 2, 2 to the second power is not 2. How about n minus 1? You have to keep adjusting the pattern like this on the test. Maybe when you make a couple adjustment, it will work. So this is the experience that you have to learn through problem solving. Does that work? When n is equals to 3, 2 to the second power is 4. When n is equals to 4, 2 to the third power is equals to 8. So this pattern works. How about the next one? The next one has something to do with the factorial. So we have negative 1 over 1, 1/2, negative 1 over 6, 1 over 24, and negative 1 over 120, ... Okay. Now, what do you see in the denominator? N times certain number is not going to work. N raised to certain number is not going to work. When I see the 1, 2, 6, 24, and 120, so this is what I am thinking. 1 factorial is 1. 2 factorial, 2 times 1 equals to 2. 3 factorial is 3 times 2 times 1 equals to 6. And then 4 factorial is 4, 3, 2, 1 equals to 24. And then 5 factorial, 5, 4, 3, 2, 1, that is 120. So this is n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5. I can see that the denominator is n to the factorial. And then what else do I see? I see that the negative sign alternates, so I will start with something like this to see if that works. When n is 1, that is negative. When n is 2, positive. When n is 3, negative. And then the numerator is always 1. The denominator is a factorial. Yep. And then how about the last problem? The last problem is factorial as well. I know what you are thinking. Hey, this is so not obvious to me. I get it, that is not obvious. That's why you have to do a lot of practice to make it obvious, to make your brain react faster when you see a sequence. 2 over 1, 6 over 3, 24 over 7, 120 over 15, and then 720 over 31. Oh, when your instructor make an exam problem, your instructor will just write down the A of n first, and then just give out 5 numbers for you to guess. It's easy to create, but it's hard to figure. The pattern is hard to figure out. Okay, the denominator, I will just write n equals to 1 to 2 to 3. Let's do this first. N equals to 4 and n equals to 5. Okay, here. The a to the n, this is what we have. The denominator is 2 to the n minus 1. So for the fourth power, 2 to the fourth power is 16. 16 minus 1 is 15. I know that is not obvious. You have to do a lot of problem solving to make your brain react faster. And then the 31, right here. When n is equals to 5, 2 to the fifth minus 1. So that would be 32 minus 1 equals to 31. When n is equals to 2, 2 to the second power is 4, 4 minus 1 is 3. And then the numerator is n plus 1 factorial. When n is equals to 3, 3 plus 1 is 4, 4 factorial is 24. When n is equals to 4, 4 plus 1 is 5, 5 factorial is 120. So basically what I'm trying to say is the 1 factorial to 5 factorial, I just memorize what that equals to in my brain. So when I see this number, my brain reacts a lot faster than people who just sit down and keep trying stuff. Once again, I memorize 1 factorial to 5 factorial. I know exactly what that equals to without touching my calculator. So once I see numbers like that, 2, 6, 24, and 120, my brain is saying that that must be related to factorial. So I start at factorial. I will just keep changing this to make it works for this problem. Alright, so that is the end of this video. Please listen to me. You have to do a lot of practice in order to react faster. Alright. If you like the way I explain finding the nth term of a sequence, give this video a thumbs up, give my channel a subscribe. I meet you all in the next lesson. Signing out. Take care.